very happy to have Ethan Ligon here. Ethan is an expert on many things in development economics and agricultural economics, but especially on risk sharing, models of the household. And I think today's presentation will fall broadly into that category as well. I've been told to remind the people watching online that there is a button under your viewing window to submit questions. And Therese will maybe tell us about those questions at some juncture.
We have them, yes.
If we have them. Otherwise, the usual econ seminar rules apply. Take it away, Ethan.
Great. I'm really pleased to be here. I appreciate the invitation. I hope the usual econ seminar rules involve interrupting me to ask aggressive questions. That's what make me feel welcome and at home.
Do we go till, what time do we go till? What's our ending time, Teresa?
I'm sorry, what?
When do we end?
End time, I would shoot for 5:15.
Okay, that's useful. Thanks. Right, so I'm happy to be here. This is a project I did with a former student, Jed Silver, who's now at Hebrew University. It's about credit and welfare across the lean season in Gombe, Nigeria. So I guess first I'm collecting terms here. When I first started thinking about this issue of seasonality, which I think is very important, you want encounters when you go places, different words or language or people talking about this. So I think whenever there's an agricultural season, there's going to be a period of plenty and a period of some hunger. I've been collecting different words from different languages to describe this, which was kind of, I guess, a hobby of mine. In the particular area where we're working, one of the main languages, there's a bunch of languages, but one of the principal ones is Hausa. So you can see perhaps there, I try this technology, oh, no, I'm not good at this. The Bakanyunwa is the name for the black hunger. And in general, we'll get translations of these from different languages. We got planting hunger, the hardness. From French, we have the soudre, the joining. Seasonal scarcity is boring. Lean months, the hunger period. So these are all sort of what economists might call a sort of primal description of a shortage that happens in a seasonal way. And this sort of colorful terms for some of these. There's at the same time some, I guess, what we might call dual representations of this. These are words that have to do with prices. So in Portuguese, time of high prices is very literal. Tempo de carestia. The word dearing comes in, like when prices are dear, comes up. Historically, in English, the word dearth comes from a time when it means prices are dear. So we have these representations that people recognize about, well, we're hungry, there's not very much food, and also prices are high. This is sort of recognition of the dual nature of prices and quantities that economists are fond of. Okay, I think that's what I have to say. So this is a prevalent phenomenon in lots of agricultural settings. If you know other words to describe the hungry season, please tell me. I'm going to add them to my collection. Okay, so this particular experiment was done in Gombe. It's a state in northeastern Nigeria, an exciting place to do field work. Fortunately, I had Jed to be the brave economist who was principally engaged in that. It's not in the Sahel. It's a little bit south of that, but it's quite arid. It's semi-arid. The agriculture is all rain-fed. There's a single harvest per year. So we're going to be thinking about one harvest season per 12-month period. The major crops there that we'll keep track of at least are maize, millet, sorghum, beans, rice, groundnut, and bara nuts. These are all storable goods. There's also a variety of non-storable, more perishable sort of goods that people consume, of course. The storable goods are of particular importance here because we face precisely the problem in this setting of having a harvest, needing to produce a bunch of food, this time of plenty, then saving it to get you through to the next harvest cycle, 9 months or so down the road. So you can save the non-perishable stuff and can't save the perishable stuff. That's sort of the nature of the problem. Something which is true of Gombe or even within Gombe is that markets seem to be fairly poorly integrated. So we have, I'll share some data with you later, but we have data from different villages within Gombe State, different market towns. We have also observations of prices elsewhere in Nigeria. The weekly price correlations, even between places that are pretty close to each other, 20 kilometers or something like that, are pretty low. And the correlation between prices for maize, for example, in Gombe and say Lagos are it's hard to reject that they're zero. So there's not a great deal, there seems not to be a great deal of spatial correlation in prices that makes us think that market integration is poor. Why it's poor is a separate question, maybe I'll come back to at the end. We partnered with an NGO called Tamaka. This is an NGO led by a couple of bright young things from Oxford who had read a paper by Marshall Burke and Lauren Birdquist and Ted Miguel. It's in QJE 2019 that introduces what they call a post-harvest loan program in Kenya. And I'll come back and talk about that a little bit more. This particular NGO had read that paper, were really excited about it, and they wanted to replicate it in Nigeria as a way of, improving human welfare. The bright young things for Oxford were well read up on the latest in sort of empirical economics and were aware of sort of the RCT revolution and thought that they would be able to, both sort of validate their project design and raise more funding if they had a rigorous impact evaluation. So they approached the Center for Effective Global Action, CIGA, which I'm an affiliate, and said, "Hey, does anyone want to do an evaluation?" CIGA gets lots of those requests. Actually, in this case, we said what we often say, which is, "Sure, if you let us also collect a lot of other data." And these young people were enthusiastic about that prospect and gave us very free rein in designing things. So we said, "Let's do that." Okay, so I'm going to tell you briefly about the things we measure. So the whole idea for us going into this was that if we're interested in seasonal stuff, we should measure stuff at seasonal frequencies. The QJA paper I mentioned earlier was a traditional RCT design. There's a baseline, there's an end line at the beginning and the end of the season. It's all about seasonal deprivation in prices, though, which they didn't measure. So we thought, well, it would be important to actually measure whatever seasonality there is to understand the problem. So we went in with the idea originally of trying to get monthly measurements of a bunch of key economic variables. In practice, we do less often than every month and a little bit irregularly, but still about every 6 weeks or so, we're able to go and measure a variety of things that are, I think, important for understanding what's going on. One of those is just a measure of how hungry people are. Here we use something called the Reduced Coping Strategies Index, which is a tool that's used by some of the multilateral organizations to measure hunger. It has questions that are something like, in the last 7 days, have you needed to eat food that doesn't appeal to you? Because of shortages, or did adults in your household forego eating meals so the children could eat, or things like that. There's a battery of 5 questions that gets points assigned to each one. They're added up to make an index. That's the RCSI. So we're going to measure frequently answers to these questions. Another sort of more better motivated from an economist point of view question is, what's the marginal utility of expenditures? And I'll talk a little bit about how we measure that. The idea, though, is very simple. It's basically, how much do you want $1 today? How much would you give? How valuable is it to you to have an extra $1 of expenditures or an extra naira of expenditures in Nigeria? So I'm going to call that lambda. For the economist among you, that's going to be the same as the multiplier on the budget constraint for the consumer. It's also the partial derivative of the indirect utility function with respect to expenditures. It sort of tells you how urgent your needs are now. We will also measure demand for savings. I'm going to call this Q. We do this very directly. What we do, well, I'll come back and talk about that more, but we're going to measure very directly how much you want to save right now. So the idea is that if it's now a time of plenty and you know that future periods are there's going to be a scarcity, then presumably you might want to save some of what you have now for that future hungry period. How urgent your need for saving is going to depend on your beliefs about, well, how your knowledge of how much you have now and your beliefs about what might happen in the future. So you're trading off these notions of what you have now and what future possibilities are. There's both a desire to smooth things out and also a desire to respond to the uncertainty, perhaps if people are sufficiently risk averse. We're also going to measure prices pretty carefully for a bunch of goods that people consume, as well as all the non-perishable grains I talked about a moment ago. So we're measuring market prices in different markets around Gombe on more or less monthly frequencies. I'll talk about variables that will show up in the talk later on are going to include, well, this P is a vector of prices. I'm going to talk about RT plus 1. Those will be returns if you hold the thing. So it's a ratio of prices. It's the price tomorrow versus divided by the price today. That's be a return to holding an asset like a bag of maize, for example. Okay, so I mentioned Q. That's how much your demand for savings is. R is returns. Lambda is your marginal utility. And RCSI is your hunger. Just keeping track of notation here. Okay, I said some of these things already. I'm going to say more about them though. So how did our project turn out? Well, we wound up settling on a design in conjunction with Tamaka that involved an RCT with 3 arms, I guess. So in one arm was the control. We'll set that one aside. Second arm was a post-harvest loan where at harvest, so the farmers had their crop outcome had been realized. They knew how much they had in terms of grain and other things to store. But at that point, we made them a loan. And the loan was for 100,000 naira. No, I'm sorry, 50,000 naira, which is roughly $100, or was at the time. With some details about the terms, but that's basically the setup. So we either gave you $50,000 in naira, or we gave you the equivalent value in current prices in bags of maize. And the idea was, well, the idea not of our paper, but of the QGA paper I mentioned earlier, is that if you made these loans to people, then they could take advantage of seasonal variation in prices by waiting for a time when prices are higher, because at harvest time, the prices are low. I'll come back to that. Let's see, so what else are we doing? We're going to collect these high frequency data. We're going to write down a model that treats pretty carefully the seasonality that shows up in the farmer's problem. I'm going to, I won't dwell on this too much in the talk, but in the paper, there's some pieces I'm proud of, which are some results on the counterfactual value of Q, or what happens to Q, this measure of savings, when you get an income shock. So I'll talk more about that later, but the basic idea is that if I give you more money, so remember Q measures how much you want to save stuff. If I give you income right now, you might choose to consume it all now. When would you do that? You do that if you previously hadn't been able to borrow. Because if you had been able to borrow, you would have already done so. So there's a sort of notion of this being a test of liquidity constraints or borrowing constraints that are a very popular sort of friction that development economists often appeal to. We say that everyone knows that credit markets in low-income countries are screwed up. Everyone faces borrowing constraints. So this gives us a test of that. Another reason, and so another way things might go, if I give you $1 a day, but the future is either you know that there's going to be less stuff tomorrow, you might want to smooth out your consumption and save to deal with that. That gives us a sort of just a consumption smoothing motive for saving. There's also the possibility, not that you know that stuff is going to be scarce tomorrow, but that there's a lot of uncertainty. And so you might engage in precautionary savings to guard against the possibility that there's a really, really bad state that you'd like to guard against, even if on average things are okay. So there's at the heart of this paper, and it's still maybe struggling to get, is a real test between a notion of credit markets or credit behavior being shaped more by credit constraints or more by precautionary motives for savings. And that winds up being key in the theory, and I think we have something sharp to say about it in the empirics. I don't want to turn this into a referendum on the QJA paper, but another sort of thing they say is that they think that farmers are missing an arbitrage opportunity because they're credit constrained. Their idea is that at harvest time, prices are low, and they observe that farmers are consuming their maize. And then maybe later on in the season, they might be buying maize back when prices are higher. So the title of their paper is Sell Low, Buy High, I think. Maybe it's Buy High, Sell Low. I forget. It's one of those two things. Their notion was that somehow if you could give these guys some additional infusion of resources at harvest time, then they could afford somehow to save their maize or whatever their grain is, storable grain is, and sell it later on in the season when prices are high. But I think I'm being fair to the logic of their paper there. Yes.
So these are what? Small farmers, large farmers was the average landholding size, producing.
That's a good question. So there are no very large farmers here. To qualify, so Tamaka was interested in engaging farmers who are actually growing maize in this case. So it had to be a household who had land, operating land at least, and could grow maize. That was one of the eligibility criteria. They also had farmers group into, they had farmers form groups of 5 or so, was notionally joint liability groups, though in fact there was no joint liability in the end. And they gave them sort of credit scores. And this is part of the experimental design, but they ranked groups by credit scores and preferred to involve farmers in the program who are more credit worthy. For sure, that selected farmers who tended to have more land rather than less land, among other things, and wealthier, poorer farmers. On the other hand, it's not like there's a huge amount of inequality among the agriculturalists in this area.
Still, we are looking at 1 acre farmer, 5 acres, 10 acres.
Yeah, I think 5 acres is probably that's probably higher than the median. 1 acre would be maybe smaller. That would be quite small. I should have statistics on that. I don't. Yeah, you're thinking of the right ballpark. A couple hectares. Okay. So finally, there's this notion. Is this an environment where there are arbitrage opportunities? That's something we'll test directly. We can construct Euler equations, sort of asset pricing restrictions here, and test those and see whether those things are satisfied. These are essentially sets of no arbitrage conditions. We'll try to reject those. Okay, let me tell you a little bit about observed seasonality here, and then I'm going to come back to the experiment and then its interpretation. This is what I need to tell you here. I need to tell you about the colors on the graph, first of all. So this is, more or less a calendar year, but it starts in November. It starts in November because November is, it's when we started the experiment, actually. So that's an important piece of the puzzle. This onset here, this fuzzy green thing, is when harvest tends to begin. And it's fuzzy because there's some variation in that, right? This is about when it starts. So we go from green, when we think about maize in particular, we've got green stalks of corn with fresh cobs on them. So that's corn one can eat. You can't store it yet because you can't store these guys aren't set up for silage or something like that. Instead, what they do is they maybe consume some, but they let the rest dry. And it might dry in the fields. It might be in a corn crib. It might be standing corn. It might be shocks. Those are all possibilities. As it gets drier, the color becomes more yellow. So it's drier. So, it's in the fields and might come out, well after the corn is mature in December or even into January. The blue area here, or purple area, whatever that color is sort of the rainy season and the onset of planting. So when you start planting depends very much on when rains start. That again is not known exactly, but it's somewhere around here, March, April, something like that. So corn, maize, and other crops get planted around here. The rains happen, crops grow, they grow up through here, and then we harvest again. So that's sort of this, those are the colors here. Now let me tell you about the actual content of the graph. This is a picture of that hunger index I was telling you about, the RCSI. So this is telling it, and so the higher means more hungry in this case. So this is it's a kernel regression of that index across different dates here. You can see that before the corn leaves the field, before the corn leaves the field, people are pretty hungry. They've got stocks now, they're not so hungry. Stocks might be getting low, or they're anticipating stuff, and then we get hungry again. So we get distinct seasonal variation in this. The gray thing in the middle is an acceptance region, constructed out of permutation tests that allow us to say whether or not the hunger index is significantly different from 0, or whether there's variation across the season. So this tells us, so beyond that, you shouldn't necessarily interpret the level of the curve too literally. This is a kernel regression, but we can say that there's a period here from around January to around September, mid-August, where people are significantly more hungry than they are the rest of the year. Or sorry, less hungry than they are the rest of the year. And conversely, more hungry after September. Do that.
And just so I
Yeah.
understand the timing.
Yep.
They don't eat the corn until it's dried.
They do eat corn while it's not dry, but they're solving an intertemporal problem here, where they're trying to decide whether to eat it now or to store it. Only the dry grain can be stored for any period of time. So
I'm just wondering, in the green region, that's when the corn is ready, or the green region is when it starts to be?
yeah, so all these, please don't interpret these colors too literally or carefully. These are about right based on FAO data for northern Nigeria. I don't have, like, the actual date of onset of rains here for this particular case was early in March. Yeah, don't hold me. This precise shade of the color is.
I didn't mean that. I just meant that it seems from the graph that September and August are harvest time, but they're actually hungrier at the start of the harvest than they are.
Yeah.
Okay.
That seems to be true of this year. Yeah, I mean,
That's exactly why they give them a post-harvest loan, because that's when they're hungriest.
well, yeah, so the loans are being offered, as you say,
Yeah.
exactly in November. So that's the story. Now, why are they hungry? If they've got all this stuff.
Yeah.
So then I'd probably point at precautionary motives for doing this. They know that they're going to stock out, that there is some danger of stocking out someplace here, and you certainly want to avoid that possibility.
And is there still uncertainty in September or October about how much yield there will be over the course of?
I think much less. So the story I would tell about, I think you're pushing me beyond the data here, but the story I would tell about this graph is that we see this lowest period of hunger here because this particular year had good rain outcomes, both in terms of timing and quantity. And so people ate more at this period than they might have otherwise because they thought that it was going to be a good harvest at this period. So there's expectations matter a lot here, and arrival of information, both in terms of when the rain comes and how well how successful they are, is a critical thing, and then some knowledge also about when harvest is going to happen, because things like the temperature and so on matter for the onset of harvest as well. So some key pieces of information here that inform you about how large your harvest is going to be in this period that people don't know before it happens.
And for the crops that you're looking at, how long can they store the grain for before it goes bad?
Yeah.
So there's that constraint as well.
So part of the intervention here involves distributing PICS bags, PICS, which is Purdue. I'm forgetting the acronym. It's basically an ethylene bag that's devised at Purdue in this state of Indiana, in order to store stuff effectively. So as long as, and so the keys are to get the moisture in the grain down below a certain level, 2%, I think, And you have to be careful about certain pests. Then you put it in the bag. Oh, the P stands for pests, yes. And so once it's in the bag, you can store it for a long time,
Like more than a year.
or more than a year.
So it's dried corn, and then when you want to eat it, what do? You put it in water?
You grind it up,
You
we grind
grind
it
it
up and
and
make
then
a
you-
mush.
Oh, okay, you make cornmeal out of it,
Yeah.
okay.
Okay, so that's hunger. So what I want you to take away from here is the seasonal pattern. Right? I will come back to that. This is the marginal utility of expenditures. And so I guess notice here that the marginal utility expenditures also has this feature that is lowest around the same period. It's a little bit later than the hunger one, but again, don't overinterpret this part, I would say. It sort of does this. So high gets low, goes high again. It follows the same pattern as hunger. There's some different patterns. These curvy bits here, you probably shouldn't overinterpret again, but I think they're probably real. Sorry. Okay. I'll stop there. Anyway, so again, I guess from this slide, I'd like you to notice that there's evidence of seasonality in lambda. Yeah.
What is the question? Is this like you ask them from 1 to 10 how much you need?
This one?
Now? Yeah.
Oh, no, this is backed out of the. Okay, so this is backed out of a technology that involves
Okay, so
estimated
this
demand
comes from
system,
a model which you'll show us later.
which I'll gloss over later
Gloss over
for lack of
later,
time.
great.
Yeah. So there's a technology I've been working on that involves estimated demand systems. So we observe the foods they consume also in some detail. So we keep track of 16 different kinds of food that they spend money on. And so we can estimate their demand for those kinds of food, which we do, which I won't spend time on today. But one of the things we get out of that estimation is measures of this marginal utility of expenditures. Okay, correct. So seasonality in this as well. So less needy here in this case, perhaps because it's been a good recent rain realization. That's speculation on that part, speculation on my part though, but pronounced seasonality. Okay, demand for savings. I talked about this Q. So this is literally us selling them one period risk-free bonds, and with a multiple price listing. So I say to Zena, if I give you 500 naira next month, what would you pay me today? That's Q. And so we trace that out over the year, roughly monthly periods. There's 2 lines on here because the solid line is the smooth kernel regression of Q given the periods we elicit these in, which were a little bit irregular, about every 6 weeks, but sometimes a little more, sometimes a little bit less. The dashed line is taking those same numbers and turning it into a regular return over 30 days. So monthly bond prices here. So maybe it might be easiest. You can see they don't deviate very much, except maybe at the end there, which you shouldn't probably worry about very much. So these are monthly bond prices though. So you can see, if we think about it this way, there's a lot of variation in the returns that they expect from this investment. And the demand, you can read this, as having a very high demand for savings when Q is high, and a relatively low demand for credit or for savings, or maybe a demand for credit when it's low. Oh, I guess in fact maybe that's a way to say it, is that when the value of this is less than 1, then okay, what else? Here's a money graph. So there's lots of different crops. I'm going to focus on maize because that's the crop that was used in one arm of the experiment here. It's also the most important of the staple crops they have. In this case, this is not using data from our experiment, but using data collected via a project that USAID used to fund called FUSE, the Famine Early Warning System. So a really nice product from that thing was high frequency prices at lots of different marketplaces across many countries in Africa. So we have those data here in Gombe from different places. We have here 11 years of data with monthly observations, and this is an average. So we've just taken we've taken those prices. We've taken the average of those over years, normalizing things. So at 1st of November, the price is always equal to 1. So we're getting rid of other secular changes in prices. Aside from the seasonality is the hope there. Again, we have an acceptance region here, which in this case is relatively small. You can see that, in fact, there is a seasonal pattern to average maize prices. So around the time when harvest is happening, prices are, what they're normalized to be close to 0. They fall subsequent to harvest. On average, they tend to rise up until harvest again, sort of pattern you'd expect. So that's the pattern of seasonality in prices that Bergquist and Miguel were hoping to exploit in Kenya, and that our Taimaka compatriots were hoping to exploit in Nigeria. There is an issue, which is that these are average prices. And the issue is this, so the black line is exactly the same line you saw a moment ago. The other lines are the actual year-by-year realizations of price series. So you can see that if you were a farmer in November thinking about storing grain and thinking you're going to make a nice certain return of around 20% if you wait 9 months, that on average that will work out, these data suggest. And occasionally you'll make out like a bandit. You'll get 200% returns or whatever. Sorry, this is not so useful. It's a 1 there. So you get really enormous returns occasionally. But actually, most years you lose money. So that's it's a very risky endeavor. Even absent the post-harvest loan, this is pretty risky. But you can see that if prices are moving around this much, we talked about the duality between prices and quantities. That's telling us that in years where those prices are really high, or years where there might be famines. So you really are facing a tremendous amount of uncertainty here.
Are those lines ordered in any way? Like if you put years on them,
Yeah.
Can you, I'm thinking of like the El Nino and the La Nina sort of cycles. Is there some sense in which things are going bad for several years and then come back, or are they just completely unordered?
I have not ordered them.
Okay.
That's an interesting idea.
That's not kind of a different sort of, it's not within year seasonality, but it's.
I don't think what I have done a little bit. I mean, annual differences in maize prices don't seem to be that predictable, at least given the modest efforts I have made to predict them. But I haven't done things like pulled in a bunch of meteorological data from El Nino, for example. I've just been a straight time series guy in this. Let's see. Okay, right. So it's risky. Let's think for a moment about what it means to issue a post-harvest loan and insist that farmers hang on to their maize. So the Taimaka contract is very much like the contract that Bergquist and Miguel used, which is basically to say, we're going to give you a loan here. It's either in maize or it's in cash. But if it's in cash, we really are going to ask you to buy maize with it and hang on to that maize, and you shouldn't sell it before July 1st or July 15th. And so that was the contract. Now it wasn't. I don't think it was enforced at all, actually. But the language of the agreement was that. So you have to get maize. We're giving you a loan to get maize, or you have maize. Hang on to it until July 15th, when we think prices are going to be high. So what's happening here? And then you have to pay back the loan. And so July 15th, you pay back. You sell your maize and pay back the loan. In the case of Taimaka, there was a 15% user fee. So you need your returns to exceed 15%.
It's high.
Well, this is in the context of interest rates are really high in this region. I'll come back to that. But what's happening here? Think about what's going on there. We're making a bet on what future maize prices are. You're doing that anyway when you store maize just for consumption. But once I give you a loan and say you have to repay, you have to hang on to this and keep it in maize, we're compelling you to make a leveraged bet on maize prices. We're dramatically amplifying the risk that these farmers are are bearing associated with the uncertainty in price realizations that we observe here. So if you have a model of the world where you know that prices are going to do this in a deterministic way, and there's a decent consumption smoothing argument maybe for doing this kind of storage. But if you think that farmers are risk averse and that this is a nice average that would be, maybe it would be profit maximizing for a risk neutral arbitrager to take advantage of. But if there's this kind of risk associated with this, that might be a really dreadful thing to do to these farmers. Yeah, Jeremy.
You mentioned that these markets are not supernaturally integrated. Does that also mean that these returns are pretty idiosyncratic across different villages?
Yeah, presumably.
Because then it seems like, yes, maybe it's a bad idea or it's very risky for these farmers to do it. It seems like they're making a bet exactly on their own. That's very correlated with their own consumption, but
Absolutely.
maybe some Nigerian company can do this.
I think the final line or my final slide, if I get there, says something like we should try to think of ways to encourage better spatial integration. So we're in agreement. We don't actually explore that in this paper, but that seems like a natural thing to think about.
Does the NGO you're working with, are they considering something like that?
Well, so sorry. So both the 1 Acre Fund was the organization that was did the original experiment for McGill and Bergquist, and although that experiment showed positive, significant effect on farm profits, 1 Acre Fund was out after 1 year. They didn't continue the program. In this case, and I'll come back to this, we convinced the NGO well before the end of the project that it was a bad idea and they should not do it in the future. There are other post-harvest loan programs that have been implemented elsewhere. I don't know that any NGO who's done them has chosen to do them twice.
Okay. Yeah, no, I was not talking about post-harvest, but talking about the spatial integration, right?
Oh, yeah.
So, for instance, they could do the information gathering about the prices across different areas.
Right. So things like Jenny Akers' work on
Yes.
using cell phones to share prices, or building roads to make it easier to move maize around, or maybe enforcement of contracts across space, or those are all ideas that might be worth exploring, which I'm not going to talk about further, except to say that maybe we should explore them. All right, so that was all just to convince you really of two things. First of all, that there's important seasonality here and stuff we care about for welfare. And second of all, to tell you sort of a little bit about the risks associated with this enterprise. I'll tell you now about the actual research question I'm interested in here, or research questions. So I've already talked about the Berkeley.He paper. And I've already said, maybe I've anticipated this whole slide, we'll see. So the idea in the Berkeley.He paper is that there's an intertemporal arbitrage opportunity. We can argue that argument rests on the notion that there's some kind of liquidity or borrowing constraint that farmers face at harvest time. So a question that a sort of logic for them was why are farmers not engaging in intertemporal arbitrage? Their answer was because they needed credit, so they provided credit. I think I have said all this actually.
Yeah.
Okay. Yeah. I'll keep going. Sorry. Here are the questions. This is what I wanted to get to. So the questions we want to answer here is, first of all, an evaluation question. And I'm going to give you answers on this slide too, so you can leave early if you need to. Does offering post-harvest loans improve welfare? The answer here is going to be yes and no. The broader question is whether or not financial interventions that are local are sort of a useful thing to explore here at all. And my answer to that is going to be not very. So if we want to think about just reforming local credit markets, for example, or changing contingencies within this area or something, it's going to turn out not to have so much potential because there's so much aggregate risk that everyone's facing here.
Yeah.
And they're not sharing it perfectly. We have tests of that. But the aggregate component of risk here is enormous. And so you sort of can't imagine a financial arrangement that just share that locally. Some kind of financial integration with other places in Nigeria we were talking about might be useful. There's other things you might do, but sort of local financial reform doesn't seem like it makes any sense. Okay, and then there's a narrow question. Is it the fact, is there evidence that farmers are actually borrowing constrained after harvest, right, when they have the largest plenitude of resources? I think it's like a funny question anyway. I mean, I was trained as a kind of macro tradition. It's aggregate resources are, you got a lot of stuff now. You don't want to borrow now. You want to save for when you have less stuff. So I think that logic works here. I'm going to provide some evidence that the farmers in our study think the same way I do. So I'll come back to that as we make progress. Okay. Oh yeah, the answer is no. All right, so here's the experiment. I've already set up parts of this, I guess. So there's about 1,000. The idea was to enroll 1,000 farmers. We fell a little bit short of it by 65, I guess. The farmers were organized into joint liability groups of 5. They self-selected into those groups by area. This goes across 15 different villages. There were sort of 3 treatment arms we were interested in. I've already mentioned one of those was to give 50,000 naira to each member of the group. A second was to give each person 50,000 naira worth of maize. And the third was a control. The way we implemented this is maybe kind of interesting. We used a sort of notion of fine stratification. So there's this old idea that Neyman had in 1923, I think, of trying to do difference in differences across strata. So you have an interaction between different strata and different treatments. That's basically what we're doing here. But our strata are very small. Our strata consist of just 6. A stratum is a group of 6. And we assign 2 of each 6 either to maize, to cash, or to control. And then the comparison, we'd sort of do a difference within that set of 2. So we have lots of strata. This is an idea that was championed by Athey and Emmons, which gives you some nice power when you can order people in the way we do, which is by some kind of notion of creditworthiness. So it's an initial assessment of how creditworthy the different groups of farmers are. We order them. We can assign strata to different probabilities and so on. Yes.
Can groups with different assignment live in the same village?
Yeah, and they typically do. Yeah, I think they always do that, in fact.
Maybe you're getting this, but what does joint liability mean?
Yeah, so I don't, so joint liability is an idea that I associate with the Grameen Bank. So we have this idea of group lending where everybody gets a loan, but if one defaults, the group is liable. These groups were called joint liability groups, but in fact, no mechanism like that was ever seriously discussed or enforced. So
That's what I was asking, because Grameen, the way they enforce that is that you lose access to future loans.
yeah, so that's
There was no future when
that's
you-
Grameen 2, actually. That's there was an original design that was relied less on dynamic incentives. So but none of that really. The word joint liability shows up on that last slide, and that's the last you'll see of it, and that's okay.
Okay, but what were the farmers told?
The farmers
The
were told
terms and
to
conditions
they were
of the
told to associate into groups, and they might receive a loan. And I don't know the extent to which they were advised that they would be responsible for each other, but I don't think very much. For sure, none of that was ever enforced. Okay, more on timing here. So this will just lay out the timing of the experiment for you. So we have the same colors here, right? So the green is when harvest begins, and yellow is when the grain is more or less dry. You can see we did a baseline survey starting in August of 2021. That took a couple months to complete. There was a sort of accident of timing. We had intended to disperse the cash loans at the same time as the maize loans. Perhaps predictably, the logistics of organizing a bunch of grain purchases and reallocation took some time. So those disbursements actually happened about a month later. We began asking questions, these monthly seasonal questions, though, a little bit earlier than that. So a happy accident for us is that in between the disbursement of the loans, we were able to start asking these questions about seasonal hunger and Q and lambda and so on. Let's see. So, right. So then we proceeded with our monthly surveys throughout the year up until October. The stuff on top is we've already talked about the planting season, the lean season, the harvest, that's all done. And line starting in mid-October of 2022. Okay. Let's see. Okay, so I said this already. This bond price Q is going to show up importantly later. I'm going to be a little bit careful about describing it. So the question is, would you invest 500 Naira at, it's actually, I'm going to be careful now. Next time I see you, if I bring back to you the next time I see you, 500 Naira times R. So I say a number in that case, 600 or 700 and so on. So multiple price listing exercise. So I start off low. I say, would you give me 500 Naira next month if I gave you 450 the month after? And you might say no, because that's a return of minus 10% over 1 month. That's doesn't seem like a great investment. If you said no, I would say, oh, what if I just gave you back 500? And you might say no or yes, I don't know. If you said no, I would say, oh, well, what if I give you back a 20% return? And we keep going until you agreed, or until we got to 100%, at which point I'd give up and suppose you didn't really want to engage in the exercise.
So was it purely hypothetical or did they?
No, so we absolutely implemented this. So we implemented this. That's one of the reasons for the timing here is because we were concerned, well, two reasons for the timing, because you'll see this is a little different from what I said. Right now I said, next time you see me, will you invest 500? That's because we couldn't rely on people having the cash when we first interviewed them.
Yeah.
So we needed to arrange in advance for them to have the cash to invest. Also, we were concerned about sort of beta delta kinds of discounting stories. So we wanted to have a clear view of the discounting and not having some kind of odd present bias messing up our measures of Q here.
So next time you went, then they actually gave you 500 Naira?
And they gave us 500 Naira, or they could actually give us more if they chose to. They could show up with anywhere between 500 and 2,500 Naira.
But they would get it back at that.
And then get it back the subsequent visit. So a month, 6 weeks later, something like that.
Yeah.
And that was the deal.
At the rate which they wanted?
Right. So then, yeah, that's an important point. So it's the rate they agreed to. Then to implement this, we chose a random number and chose a random number from that, in fact, and we implemented the deal at that number if it was more than the number they agreed to.
The minimum.
So if you agreed to a 10% interest rate and we rolled a higher number, you'd actually get the higher number.
Okay.
But you would have revealed your preferences though.
Correct. Okay.
Just give me, I don't know what, like there's obviously variation in levels across the villages of what people are spending, but like what is average monthly household expenditure and how does it compare with what you're offering them here?
I hesitate to go out on a limb on total household expenditure. The expenditures we measure are going to be numbers that are like between 30 and 50 bucks.
30 and 50 bucks. And your loan is $100.
Our loan is $100, but they have to pay it back.
Yeah.
I'll come back to a calculation of the present value of
Okay.
that later. Maybe that's the time. But this, oh yeah, that's important. Yes, I'm sorry. Here's the question I wish you'd asked.
Oh,
sorry.
sorry.
Which is how much is 500 Naira?
Yeah.
That's about $1.
Yeah, that's
So
what I was trying.
So our
Yeah.
It's small stakes.
It's small stakes, okay.
Yeah, our intention here is to give a big loan
Yeah.
that we think might have income effects, might really seriously affect their risk attitudes and so on. And then to have these little bitty loans, those little bit of saving opportunities to measure their intertemporal margin rate of substitution, the demand for credit. That
How
won't
many
have,
people said 0 or negative?
Yeah.
not very many people said 0 or negative, but it happened.
It happens because there's different motivations, right? So people want to keep their money safe.
Yeah.
People
Absolutely.
anticipate temptation
Yeah.
and
I agree. I mean, there was, I don't know if I have a good slide on this. There's some in the paper. There's quite a lot of cross-sectional variation in the cues that people report, which we think is real. There's also just people being confused.
Yeah.
There's an issue here. This is a very Muslim area. This is a very conservative Muslim area.
Yeah.
Credit in general is haram. So we have to be careful about how we talk about this stuff. In our very first round of this, a lot of people just refused to do this, either because they were concerned about the fact that there was usury involved, or because there was gambling involved. Because remember, we're randomizing stuff.
Yeah.
And so we had to have careful conversations with the village imam all over to sort of sort that out and get their approval, and then things went more smoothly. But that was for sure an issue. And I think that despite the reassurance from the imams, increased sort of compliance and participation in this tremendously, but there were still some people who sort of never engaged with it and wouldn't save at any rate. So and I don't know if that's for religious reasons, or if they just didn't trust us, which is another issue we'll come back to, or they just, who knows? Or they, okay, what else? I think I've said these important things. I'll note that just the bond price Q we're eliciting is the reciprocal of this risk-free rate we're eliciting. There's a discussion in the paper about whether or not we can interpret this as the risk-free rate if people don't trust us. I'm going to leave that alone for now, unless there's time, perhaps. I'm going to call Q the intertemporal price. It's really, how much are you willing to pay now for $1 next period? That's the way I'd like you to think about it. Yeah.
Inflation over these 2 months.
Yeah.
Is that, I'm sure.
So inflation over the course of this year was about 13%.
It's like 2%.
Yeah. But there's probably some variation in that across months. Let's see, what else? There's something else I wanted to say about that. Perhaps it'll come to me. And there was a devaluation in 2023, I think. That was a 33% drop. People might have expected that devaluation. So who knows what inflationary expectations were, right, aside from the realization. So that's important here for sure.
A bit less here. It's a more isolated rural area.
And they're still using cash for stuff.
Yeah, but the devaluation matters less because they're not so integrated with the global economy.
That's I suppose that's right. Something else I'll say is that the commercial prime rate over this period was around 27%. So subtract 13% from that, and you get a prime rate of about 13. So interest rates are very high, even for commercial firms in Lagos. Okay. All right. There's lots of numbers on this table. I don't really want you to read them. They're probably too small anyway. What I want you to notice from here is that we've got these two treatment arms, cash and maize. And when we give people cash or give them maize, they readjust their portfolio some. So that leads to people who receive maize, people who receive cash buying maize, so they increase their grain stocks. It increases harvested grain. I'll come back to that. That was something that confused us that we only understood later. We see purchases for storage. All the stars here involve changes in portfolio allocation because they gave you one asset and you want to change it to a different piece of the asset. What else shows up here? I guess the first takeaway I want is, aside from those portfolio changes, both these loans have similar effects on behavior. There's almost nothing aside from that where we have stars show up. And so for practical purposes, we think the main effect of this was just receiving these resources, that's the main thing that was going on for the households. And the form of it didn't matter very much. If it was maize, you'd readjust. If it was cash, you'd readjust some until you had similar portfolios. Yeah.
So I'm just trying to understand the second column, maize, difference between maize and control. So purchase of storage has actually decreased for maize treatment arms.
Because they
Right.
got maize, so they don't need to purchase
Right,
maize.
so they were given,
They got bags of maize.
Oh, because it was storage, for that, that's like a storage area, it's like a actual maize.
Yeah, actual maize
Yeah.
purchased for storage purposes.
yeah, exactly, thank you, exactly. Right, oh, yeah, so the takeaway is those two treatment arms are very similar. So we'll think of this mainly as being similar treatments for household welfare elsewhere. Okay, all right, so, yeah.
In some sense, local markets there's not market frictions in converting maize to cash and cash to maize. There's
So,
not an aggregate shortfall or something like that.
so the markets for, even in these pretty remote villages, the markets for maize and other grains also were pretty active.
Right.
You could absolutely buy and sell them.
Yeah, no, that's what I'm saying.
Or
The fact
cash,
that the two
or
treatments are similar seems to
And
indicate
we were
that.
surprised, an anecdote is, telling these stories about, well, gee, people should be trying to save maize perhaps as an asset, because prices are going to go up. People were doing that. One of our enumerators, who was not a farmer, was buying maize and putting it in a mini warehouse in hopes that prices would go up and he could make some money, for example. So, and that's just one enumerator, but I think that was not an unusual behavior. Okay, what else? Let's see here. I think I've said this. Right. So think of the receipt of this loan as being similar, whichever treatment arm you're in. The next thing I want to say here is that it's not really a loan. So this is really, I think the better way to think about this is a weird cash transfer. So why? Well, a couple of things. First of all, there's this 15% user fee over 9 months. So that translates to about 25% interest. We'll see. I've already told you that's below the commercial prime rate. So this is clearly a subsidized loan, even on those terms. The actual interest rates people are willing to pay when you get these Qs give us interest rates much greater than that. The monthly interest rates that people are willing to pay their Qs range between 3 to 13% per month, depending on where you're at in the year. See, I said this thing about the prime rate. And there's a ceiling, as there was in the other thing. There's a ceiling of how much you could borrow. In this case, you had some choice about, but there was a maximum, and all but 3 farmers chose the maximum. So that tells me these guys are at a corner, and we can't think of this. Think of this as credit is not very useful. If this is truly credit, we think about people trying to equate their intertemporal margin rate of substitution to whatever their returns are. There'd be an inequality sign in that Euler equation. Here, there's an inequality. These guys are at a corner. They are just going to think about this as a net present value cash transfer at the time they receive it. Yeah.
It's happening with default. Do they repay?
Yeah.
I'll come back to that. When I gave the answer to is welfare improve, I said no and yes, maybe yes and no. So yes, when you receive the loan here, it has positive net present value, and we'll see that people respond to that. Let's see, I never know whether to keep secrets or not, how much suspense to build into a talk.
No. We are desperate to know the answer.
Okay, right. I'll spill the beans, which is that this particular year was one of those years where harvest was good. Prices stayed low. This leveraged bet was not a good bet at all. And then these guys were asked to pay back the loan in July.
At the time when prices are
And
low.
the time when prices are low, and you can see that their welfare. So at the beginning, they're wealthier, they act wealthier, they buy better food, their lambdas are lower, their consumption is higher. At the end, the ones that pay back, but it's not all of them, have lower lambdas. Higher lambdas. They have more need, and they're worse. So ex ante better off, ex post worse off.
Why do they pay back? What's the incentive?
Well, I don't know. So originally we thought they were going to pay, or the Tamaka thought they were going to pay back because they were planning to continue this program, and they'd be excluded if in fact they didn't pay back. In fact, before the end of the program, we convinced Tamaka that this is a bad idea and they should stop, and word may well have leaked out. So I don't. The real question is why didn't everyone default? And the answer is I don't know, because they either didn't know and they thought they might be eligible for this program in the future, or because they felt compelled for ethical reasons to repay, or I don't know, outside my expertise.
It's a rule following people.
Okay, right. All right, so I think I've said this. So the net present value of this thing wound up. So if you do this, it's a careful calculation of the paper. There's more details to the loan. They're supposed to get the 50,000 IRA and then pay back a certain amount per month. And there's a 15% fee they get back at the end. There's some transportation costs for the maize. The contracts are a little more complicated than I've said. If you tease out all those things quite carefully, then it winds up being in a table and then the appendix to the paper. Roughly the net present value to the median household here was about $50. So $100 initial, but 50 net, ex ante. Right. Let's see. I think that's it. All right. So we're giving so I want you to reframe things now, mostly. And think about, okay, the experiment now is giving people randomly about $50 at harvest time, and then seeing what they'll do with it. That's now the interesting question. And there's some interesting details like the default or whatever, but right now the conceptual experiment is that. If I give you $50 at harvest time, do you consume it? Do you save it? What happens to other stuff? That's the question. Okay, something to bear in mind is you've already seen there's a lot of seasonal variation here and a lot of variation across years. The aggregate shocks here are real and big. And it is the case that our $50 is a lot of money for these farmers, but it's still sort of dwarfed. The treatment effects we're able to induce with this $50 transfer are very, very small compared to the seasonal stuff that happens in almost everything we measure. So here I've just, well, I guess I've already shown you this figure. This is the seasonal variation. This is not useful here, I'm sorry. We need to see the treatment effects. Okay, here we go. So here's an example of a set of treatment effects. So there's a ton of figures like this in the paper, not so many in the talk because I have limited time. The way to read this is that to the left of the line is either an average or a sum, depending on the variable, across the entire season, and then we do it wave by wave. So for each wave, we have a little test of whether or not there's a difference between treatment and control for the outcome we care about. This particular outcome is the value of grain consumption from own stock in that period. And so you can see how much people are eating out of their grain stocks here. You see one significant, there's little stars here, which tell you this is significant, in this case for the cash loan. And you can also see from this figure that grain stocks, or you can infer that the size of grain stocks is getting very small as the season goes on. The big thing I like to notice here is that even though you've given people bags of maize, when we generate some significant treatment effects, that variation is quite small compared to the variation we see across waves because of aggregate changes.
But is this value, but how much is it because of quantity or how much is it because of price? Because the price also changes dramatically, so.
Oh, I agree. No, this is, you should read you should read this table and others as just very straightforward, agnostic RCT kinds of double difference things.
Right, no, but I'm just wondering when I'm thinking of welfare.
Yeah.
Are they really going hungry? That would depend on the quantity of maize consumed.
Yes.
Right, if all of this variation is just from price, then they could be consuming the same amount all the time.
You see on the average from the hunger figures that I've shown here that people go hungry when prices are high, or that tends to be the case. There's still cross-sectional variation. I'm sure that not everyone is always hungry.
Yeah.
When we look at individual consumption items, I use that to estimate these lambdas, this measure of how needy you are in a given period. We see some nice variation in that, both cross-sectional and cross-time. I'm exploring the cross-time stuff here, but there's also interesting cross-sectional stuff, which I'm not going to have, I guess, time to explore today. Okay, I see that I have about 10 minutes left, so let me move quickly through the theory and tell you just the parts you need to know. There is a model, however. Let's see, no. Okay, here's a couple of parts I'd like you to notice. So there are first order conditions from the consumer's problem within a period. So this just tells us, this is a usual relationship that tells us the marginal utility of good J for a consumer making choices between maize and goat, for example, is going to be equal to the price of, the price of whatever the good is, multiplied times lambda. Lambda is this measure of need, the marginal utility of expenditures we got kicking around that shows up in every single first order condition for the consumer's problem. I'm going to use that variation by measuring demand for goat and maize and rice and bambara nuts and so on in order to estimate lambda for every household every period. So that's the preferred welfare measure we're going to use here, is this measure of need associated with how much you really would value in having $1 today. Okay, that's one equation that's important because it tells us lambda. The second is this equation here. So this is an Euler equation. This ratio of lambdas times beta is the intertemporal marginal rate of substitution. This ratio of prices is the return to holding asset J. If there's no credit constraint, then that ratio will be equal to 1. That will be equal to none. If you are constrained, if you're at a corner, then eta will be a positive number, and this will hold with inequality. So we have a theory that tells us that this equation will hold if you're not at a corner, and this equation will hold if you are. And so we have a nice testable set of restrictions there. Okay. Let's see. I'm going to zoom through this too. This is meant to illustrate some of the geometry of consumer choice, intertemporal choice for consumers when there's uncertainty. I guess I won't dwell on it though. Okay. All right. So here, I'm sorry. This is actually the elegant part of the paper. I'm going to skip over it. So M is the intertemporal marginal rate of substitution. R is our returns. So people who do asset pricing will see this, and that'll be very familiar. We're multiplying it by delta, which is a little bit novel. That's a dummy variable, which takes the value 1 if the asset's held by the agent and by the farmer in a positive value, otherwise 0. So this holds for everyone in the economy, but it's just zeros for those who don't hold the asset. That allows us to do a nice aggregation trick. We construct the average marginal rate of substitution for everyone who holds the asset. If we had full insurance, if things were fully efficient within the village, then everyone would have the same M. We have this restriction, which has to hold by complementary slackness. So this is going to be a more familiar looking asset equation, but it holds for the average for everyone in the village who holds asset J in positive quantity. Okay, I'll keep going. Okay, this gives us a nice test because we can subtract the idiosyncratic intertemporal margin of substitution, or subtract the aggregate from the idiosyncratic. That gives us an idiosyncratic measure of risk that's borne by each farmer in the village. So we've already said that the aggregate is moving around a lot. We need to control for that in an appropriate way. These M's allow us to do that. So I just, these M's allow us to do that. This gives us a nice test of no arbitrage conditions, which we'll construct. I think I'll just tell you now that we are not able to reject no arbitrage. So there doesn't seem to be any reallocation of portfolios of existing assets that people are holding that would lead to better outcomes for farmers in this village, or at least we can't reject the null that there are not. Okay, there's a clever decomposition of this demand for savings. This is the price you're willing to pay for $1 next period. We can decompose that into a piece which involves a certainty equivalent. So if I know for sure that there's going to be less resources tomorrow, then the QCE tells me how much I'm willing to pay in order to smooth out my consumption in that deterministic way. There's another piece here which we need to relate to the curvature of the marginal utility function. It's this piece defined here in the second line up here. This is a sort of Jensen inequality kind of thing that tells us how important precautionary savings are. So we're able to decompose what you're willing to pay for savings into a piece which is, I know I'm going to have less stuff tomorrow, versus I'm worried I'm going to have less stuff tomorrow. Those are two different things. We're calling, yeah. Okay, so I want you to think about, I'm going to introduce an operator nabla. So this upside down delta is nabla. Nabla here means counterfactual, and we're going to think about the difference between somebody who, in some state of the world, received this income transfer of $50 versus somebody who didn't. So the nabla Q here is the difference in their willingness to save between those two states. So think of two identical people, one of whom randomly gets $50 and the other one who doesn't. That's the nature of the experiment. That's what we're measuring. There are two worlds I'm interested in distinguishing between here. One of the worlds is one in which I'm facing a borrowing constraint. So if I'm facing a borrowing constraint, that means that I would like to borrow from the future to consume more today. That's what a borrowing constraint is. If I give you $50, you're going to consume most of it, perhaps all of it. You won't save very much of it. If you would save very much of it, you wouldn't have been borrowing constrained to begin with. So if I give you $50, then I know that this nabla Q should be a positive quantity. I need to be induced in order to save, because I would really like to borrow. Okay. Conversely, with a little bit of restrictions on the curvature of the utility function, which are necessary to pin down motives for precautionary savings. So there's two constraints here. I should have defined these earlier. So DRP is decreasing, this actually should be DAP. It's decreasing absolute prudence, which is a condition on the third derivative of the utility function. It needs to be sufficiently curved there. And the other is decreasing relative risk aversion. So I need both those things to hold, and then I can give you a very sharp, if and only if, mapping between nabla Q and being constrained or unconstrained. Okay. Right. So this is some discussion of these preference conditions, which I'll skip over and further skip over. Okay. So here's an illustration of this. In this regime, the consumer is constrained. If I give you $50, you'll move from this point to this point. This is consumption at time t, or your budget at time t, and you won't change your budget for future periods. So here's I'm gonna tell you this, and I'll tell you, this is a hypothetical. So I've got a simple model set up here, just semi-calibrated to the actual data. I'm working on doing a better job. But this is what, in this little sort of semi-calibrated model, the predictions we get in this experiment. So the idea here is that in this first column, XT is the budget you have today, and XT plus 1 is the budget you have tomorrow. The budget you have tomorrow depends on whatever your realization is, plus whatever you save. So in this world, I'm going to imagine an experiment where I give you some additional resources. I'm going to move you from having 5 today to 8 today. If you're unconstrained, you'll take that money and you'll reallocate it. You'll save, in this example, 8 minus 6.47. So that'll be the amount you save for the future. Giving you a budget next period, which is actually a little bit larger than your budget today. That's 6.47 versus 6.53. A constrained household will just consume the entire thing today, leaving the original budget of 5 for next period. What effect does that have on lambda? So lambda, remember, is the need, how much you value $1 today. This nabla log lambda t is smaller for the unconstrained household. Why? Because they're consuming less. They still would like more resources today. The change for the constrained household is larger because they're consuming more stuff today. They're And finally, this is the key part I'd like you to notice is this log Q. The unconstrained household has a negative value for that, and the constrained household has a positive value. All right, so those are predictions of the mod. So that there's a sharp prediction on nabla Q from the theory. I've cooked up some numbers here from a semi-calibrated model that does this. Let me skip ahead to the actual result because I can measure these things. So here you can see in the control households, there is a positive effect on lambda, which matches the other case, and there's a negative effect on log Q. However, the difference between treatment and control, that's the case because they're getting some nice surprises perhaps. The difference here between treatment and control is what you should focus on. It says there's a negative impact of getting resources on lambda. People are better off from having received this. But also the second number is the money number, minus 0.03, tells us that at least the average household in the circumstance is more interested in engaging in precautionary savings than they are in consuming stuff today, which tells us that they're not credit constrained. I think I'm out of time. Should I stop there? Great. Thank you all very much.